Hey there, this video is for section 11.1. This is specifically about finding interior and exterior angles of polygons. Before we start, take a quick second and see if you could remember how to classify the following polygons based on their number of sides. So for example, a three-sided shape is called a triangle. Okay, so go ahead, pause the video, and then resume to see if you missed any. Okay, here are the names of your basic polygons from sides 3 up to 12. And remember, anything past that, for example, if you had 13, we would just call that a 13gon. Okay, so you will be responsible for knowing these names moving forward. If you don't know them, then you got to study them. Okay, a couple things to just kind of recap before we continue. Just to review, when you've got a triangle, all three angles add up to be 180 degrees total, right? And sum of interior angles for a quadrilateral, all four angles will add up to be 360 degrees total. So what we're going to do in this video is kind of investigate how could we find the sum of interior angles for any shape, pentagon, hexagon, heptagon, etc., and then how could we use that to develop a rule for any n-gon. Okay, let's start out with a convex pentagon. Remember, that's any five-sided figure that doesn't have any caved-in sides. Okay, and then you're going to pick one vertex and connect this vertex, connect as many diagonals as you can only to this one vertex. So in this example, there's only two diagonals. Now, if we take a look at what we've just created, we basically made three triangles, and we know that inside a triangle, the sum of all the interior angles are 180 degrees. So now for a pentagon, I can kind of see, okay, here's 180 degrees, here's 180 degrees, and same thing here. Well, if I put all those together, it will give me the total angles inside of this pentagon, and that's the interior angle. So the sum of interior angles for a pentagon is equal to 540 degrees. Okay, so that's just a quick little investigation. You could do the same thing for a six-sided shape. Pick one vertex, draw your diagonals. By this time you've got three. So it creates four triangles, each with 180 degrees. Okay, so now this is going to be a different sum of interior angles. Pause the video for a second and jot down this chart, and when you're ready to go, then click play. Okay, so first of all, we know number of sides based off the name of the polygon. Now we're going to go one at a time. So a quadrilateral, we know it's got one diagonal from one vertex, and we were able to create two triangles from that one diagonal, right? Each triangle has 180 degrees, so that is how we know that the total sum of interior angles for a quad is 360 degrees. Okay, we also just did this little investigation for a pentagon. Remember, we made two diagonals, which made three triangles, and that's how we got a total of 540 degrees inside of that pentagon. Okay, we also did it for a hexagon, three diagonals that formed four triangles. And what do you think is going to go in this box? Good. If you said 720, then you got it right. Okay, so some of you are already starting to form a pattern. 1, 2, 3. For a heptagon, seven-sided shape, we're going to have four diagonals, five triangles, and what do you think is going to be the sum of interior angles? Take a second and see if you can finish this chart for the octagon as well. Good. Okay, so now what we want to do is see if we can find any relationships. So when I compare the number of sides, remember that's n, number of sides to the number of diagonals, can you find any type of pattern from 4 to 1, 5 to 2, 6 and 3, 7 and 4, etc.? Okay, notice how they're all 3 less. Okay, so if I want to say the number of diagonals in terms of n, it's going to be 3 less than n or n minus 3. Okay, same thing. See if you can find a pattern for the number of triangles relative to n. right? 8 to 6, 7 to 5. Every time it's 2 less, n minus 2. Now, how did we find these? Sum of the interior angles. Remember how we found those? Just by taking the number of triangles we had times 180 degrees in each triangle, right? So if I have n minus 2 triangles, I'm going to take that times 180. Now this is important to make sure that you put n minus 2 in parentheses, because you need to calculate this before you multiply times 180. Okay? Okay, here are some examples. So in your notebook, jot down, find the sum of interior angles for a convex octagon, 15gon, and dodecagon. Okay, remember that the formula that we're using, we just created it, n minus 2 times 180. So first step, you need to figure out what's n. If we're talking about an octagon, n is 8. So we have the sum is equal to 8 minus 2 times 180. And this comes out to be 1080 degrees. Make sure you put the little degree symbol on your answer, right? Now see if you can try it for a 15gon and a dodecagon. Remember that n is 12. So again, just to kind of recap, you're going to take that value for n depending on the polygon you have and just plug it into the formula, simplify, and then you're done. Example D says, the sum of the measures of 7 interior angles of an octagon is 960 degrees. And what this means is basically we've got an 8-sided shape. We know that 7 of the angles add up to be 960 degrees. The question is, what's the last missing angle? Okay, first step is to find the sum of interior angles for an octagon. So we just kind of did that. 8 minus 2 times 180 equals 1080, right? That's what they should add up to be. So I'm going to take my total minus what I have. That will leave me with my leftover 8th angle. So 120 degrees is the measure of angle 8. Okay. So we just learned how to find the total interior angles for any polygon. Now what if we have a regular polygon? There's two things that are important for a regular polygon. The angles are congruent and the sides are congruent. So those are the two ways that you can identify a regular polygon. Now if all the angles are congruent, that means I'm going to take the total, what we just learned, n minus 2 times 180, and divide that into the number of angles that we have for this polygon. Okay, so for example, an octagon, n is 8. So I'm going to do 8 minus 2 times 180. That's going to give me the total angles inside of an octagon, but I only want 1, so I need to divide it into all 8 of those equal angles. Okay, so this is 1 angle, 1 interior angle. So we get 1080 divided by 8, 135 degrees. Okay, now try it for a heptagon. N equals 7, undecagon, n equals 11. When you plug into the formula, you should get 128.6 degrees for one interior angle of a heptagon, a regular heptagon. And then for a regular undecagon, you should get that one interior angle is 147.3 degrees. Okay, now we're going to talk about exterior angles of a polygon. And exterior angles of a polygon are these angles on the outside of a polygon when you extend one of the side lengths. So these angles here are all exterior angles of a polygon. Now watch what happens when you put all the exterior angles of a polygon together. Okay, so basically you can see that when you put all the exterior angles together, it forms a circle. And we know that within a circle, there's a total of 360 degrees. Okay, so we just saw how the sum of exterior angles of a polygon total up to always be 360 degrees, regardless of what the polygon is. And what we're going to do now is use that idea to find one exterior angle of a regular polygon. And again, we're just going to take the total, 360, divide by the number of angles that you have, which is going to be n. Okay? Take a second to jot down these three examples. So we're finding the measure of one exterior angle of a regular dodecagon. Remember, that's 12. Octagon, 8. And then part C, we'll kind of talk about 2 together. Okay? So for one exterior angle, we have 360 divided by n, which is 12. Okay, so all you have to do is type that right on your calculator. 360 divided by 12, we get 30 degrees. Okay, same thing here. One exterior angle equals 360 divided by 8, which is 45 degrees. Okay, now part C. It says one exterior angle of a regular pentagon equals x plus 3. Find x. Well, first of all, we need to find out in degrees what is the measure of an exterior angle if n equals 5, since it's a pentagon. Okay, so one exterior angle equals 360 divided by 5. I'm getting 72 equals 72 degrees. Right, so now I have 72 degrees equals x plus 3. Okay, so I know now x has to be equal to 69. And that's it, okay? Stay tuned for the next video, which is going to be using interior and exterior angles to solve for side lengths of a polygon. Okay, thanks for watching. Hope this helped you out.